Alright, hello everyone. Today I want to demonstrate how you can use delegates in C# to help you when you are developing in Godot. If you already know how to use delegates with C#, this probably won't be very helpful for you. So, first of all, what is a delegate? If you have used Godot signals, the C# implementation for Godot uses delegates for signals. So basically it's just a method reference that you can call at some point later in time. So you set the reference to a method and then some point later in time you can call it. One thing that is not used for Godot signals is the ability to return a value. So a delegate can also return a value, which you cannot do with the signals that are built into Godot. So what could you use it for? In my game, I have two use cases for it. First of all, I have a player character where I have power-ups and perks for the player that they can obtain, which then will modify statistics on the players, such as hit points or damage or something else, ammo capacity in their magazine of the guns. And for this, I use delegates, where I basically just every time I need to check the value, I will run the value through all the delegates, and then I will get the modified return value. I will of course give you an example of this, and I will show you how it functions in my game so that you can see how this actually works later on. The second use case is that maybe you want to do a callback at some point later in time, so you want to set something up and say, when you need this value, check with this function, and then you will get your value. I use this for my AI, so my AI is entirely based on delegates. So first, let's take a look at this example project I have created here. You will see there are 3 cubes flying around here, and when I move my mouse over them, they stop for a second and they blink. They just follow the mouse. So if you look at them here, this is the top left cube here, you will see we have a blink modifier value here, and we have an AI node reference here up to the top right. Here's a smaller cube where I set the blink modifier to 0, and then there's a big cube down here where I set the blink modifier to 2. So if we run it now, you will see that this big cube there, the top left one, it stops for the duration of the blink and then keeps moving. The small cube just keeps moving even while blinking, and the second big one stops for the double duration because I've set it to 2. So the duration is then multiplied by this value through a delegate. So let's take a look at how this is done. So if I open up my project here, we can start inside. This is my monster base class. Here I have, there's a lot of values here, but the ones that are relevant for this part is actually not in here, it is in here. Here we have our blink modifier and the blink cooldown time. So if you look at how these are used, we will see that the blink cooldown time is used down here inside the blink function, where we travel to in our animation state machine to the blink animation. Then we set the cooldown to be equal to the cooldown time, and then we call apply single argument delegate on the cooldown and set the cooldown to the return value. So how does this part here work? Well, we have this Delegate Manager class here, which is something I've implemented here. This initial class just contains the type of modifiers we have. Here you could, for instance, add if you had a player damage modifier, if you wanted to modify the damage, whatever you want. For this example, there's only blink speed. And if you go into this Delegate Manager, this is a generic class that you can copy and just use in your project. It should be good to go as it is, and it can handle pretty much any type of delegate that has one parameter and one return value. So how it works is that you will add a delegate here, where the group, which is the int value of this enum that I have here, and then a unique key for the delegate. In this example, I'm just using a random number, and then the delegate function itself. And this will then be added to this list. You can call get delegates, or you can remove a delegate, but we don't use these. Instead, we call this generic function here, apply single argument delegate, with the group and the variable. And then it will find all the delegates that are in this group, and it will take the input value here, put it in here, call or invoke the method on it, take the return value, put it in, and then it will loop over any delegates we have and keep applying it until we control our delegate and then return the value. So if we go back to the follower here, you can see that in the ready function, I add a delegate. This, of course, doesn't have to be done from here. This can be done from anywhere, which I will show you later in my own project. And I add it to be the blink speed modifier, and I add it to call this method that called modify blink speed. And all this method does is take in a value and multiply it by our blink modifier, and then it returns the new value. So if we now go look at add float delegate, you will see this calls another function, and here we also have an add bool delegate and add vector delegate. I don't use those in this example, but I left them in here so that you can see how this is done. And this add delegate function itself just gets a random ID, as I said earlier, and then it calls add delegate on delegate manager with the int ID of the group enum, the random ID, and the function that we want to call. And that is it. Here is also a remove delegate, which is not used in this example. So what happens then? When we try to blink, it of course goes here, and then it finds this delegate that we added up here, and it will modify the cooldown time by this value. So now I'm going to switch projects, and let's have a look on how I use this in my own project. So here we are in my own project, and we are looking at this is a float percentage modifier class. It's a simple class that allows me to add a modifier to a character that modifies a percentage value. I'm not gonna go very deep into the details of the exact implementation. You can see here we have these groups for the type of modifier we are modifying, and then we have a modifier value, and when this ready function is called, we just call add float delegate to call this modify float value method, and it's exactly the same as in the example I showed you. And how I actually use this, if we open Godot here, I can show you how it's used. So if we go in my character modifiers here, we have, for instance, something like double damage, which uses this float percentage modifier script here. There are some other parameters inherited from other scripts, but I have this modifier value, so 2, I want to double the value, and I select the value, which is a damage modifier. And then if we go into my character base, or my player character, which should be here, and maybe, or actually even easier, we can go in here. We take the damage modifier, we see where it's referenced here. So you can see when it's called by this apply damage modifier class, which is called here when we hit the target. So when we hit the target, we take our damage and we apply any modifiers we have. And this is how you can use this to modify values on the fly, and you can apply effects and remove them again by applying or adding delegates to the list and then removing them again when you don't want them to be active anymore. Alright, so now let's take a look at the AI system. Alright, so here we are in the BehaviorNormal class, which is the root class for my or my abstract class for my AI system. And what the important things to note here is that we have a state, like a return state. So it could be a failure, it could be a success, or it's running. And we have this evaluate function, which is the one we always call, and it will return a state. So now I'm going to look at the two most common implementations here, which is action is the first one. This is where we have defined the delegate up here at the top, and then we take in a delegate that conforms to this definition. So basically a function with no parameter that returns a Boolean value. You can ignore these two, these are just for debug. Then we store this inside here, and when we evaluate is called, we just call it, we check if it's true, and if it's true, we return a success. If it's not true, we return a failure. And we can look at this condition, which is a if then else, and it's very, very similar. We have this evaluation delegate, same thing, just defined no parameters that returns a Boolean. And here we have the constructor where you say, if it's true, it should run this behavior node. If it's false, it should run this behavior node. And this is the delegate used to evaluate. And when we look at the implementation, it's very similar. We call the evaluation. And if it's true, we call the evaluate method on the true behavior node. And if it's false, we call the evaluate method on the false behavior node. I've also included a couple other examples here that I use for my own project, but I don't use in this example, such as this one where we execute an action, but we don't check the return, and we call a follow-up node. So if you just want to do an action and then resume with further AI evaluation, you can do that. Here we have a parameterized conditional. So you can have a method that contains a parameter here of any type you want, as long as this method takes that parameter in and returns Boolean still. And other than that, it's exactly the same. It just calls the true or false behavior node afterwards. And here's the same for an action, where we have a parameter for the action. But it's identical. This is very easy to extend. You can pretty much copy paste and modify it as you want. And let's look at now how the actual AI is built. So if you remember from the example, which I can open once again, these little blocks here just follow the mouse around, and when the mouse goes over, they blink, and then they resume following the mouse. And this is all this AI does. So let's see the implementation here. We have this. First, we have this is-mouse overcheck. I will show you how it's implemented a bit, but as you can see, this is a behavior node conditional. So, and if then else statement, and if it's true, we go to this blink check here. If it's false, we go to this blink or move. In the blink check, we also have a if then else, where you check is blink ready. If we do, we execute the action blink. If it's not, we go to blink or move as well. And finally, we check in the blink or move, are we currently blinking? If we are, stand still. If we're not, move towards the mouse. So let's take a look at these shorthand implementations here. These are just simplifications I made here in the base class because it makes it easy to reuse these things in different AIs, because all the AIs will inherit from this AI builder class. You will see that later when I show you the code for my own project. But all I do here is create a conditional behavior node that uses a delegate, is this is-mouse over method in my monster class, and this just returns this is-mouse over variable, which I set inside here in the inheriting class on the on-mouse enter and on-mouse exit. So if you go back here, yeah, and the same is true for all these actions. All they do is make a behavior node of the type action, which says call this blink method. These are virtual as well because they are overridden once again in here. What does blink do? That travels to the blink animation and does this cooldown thing that we looked at earlier. Here are the is blink ready, is blinking. All of this stuff is in these classes. So all we're doing here in the AI is basically just telling it which methods to check in the monster class, and then we can write all our logic in here in a very simple and easy to understand format. So that's pretty much it. I will now show you some more examples from my own project for some more advanced AIs, so you can see how you can use it for your own. On your own. Set up my AI, just to have a look at it. If we go in here, you will see this is my follower, the thing that follows mouse. In here I have an AI node that I attached to script. The script I attached here is the basic AI builder, which is the script we just looked at. This one here. They all inherit from the AI builder, which has this build AI that returns a behavior node, which is basically this class here. And if we go into the monster, again, the monster base class, which is here, you will see that when it's loaded, we have this load AI. It checks if we have this, if this AI node is set, it takes it and it calls build AI, and it puts whatever is the root node into AI, and then we can simply call evaluate on it. And that's it. That's how my AI for my game works, and that's how the AI in this example works. So here we have an example from my own project with a little bit more advanced AI. You can see I have more methods in my own project, such as this is skill ready, which checks if a skill from a skill slot, as my monsters have skill slots, checks with the monster if this skill is ready. And if it's ready, we can call something like use skill. So I also have all my different AIs are here. So we have a very simple AI, such as this one that just idle, the monster will do nothing. Then we have something like this, where the monster checks if it has a target. If it has, it will check if some skill is ready. And if the skill is ready, it will use the skill. If not, it will check if it's in a normal attack range. If it is, it will attack, or if not, it will move. And that's fairly simple. And then you have something like my final boss AI here, where it's similar. It checks if there's a target, checks if it's in range of some skill, checks if this given skill is ready. If it is, use the skill. If not, check if the second skill is ready. If it is, use the skill. And finally, check if we are in range, and if we are attack, or if not, move. So this is an example on how you can have a monster use multiple different skills with a very simple AI script. Alright, that's it for this video. So if you have any questions, feel free to add them in the comment section. Or if you're interested in C# development, feel free to subscribe to the channel, as I will be posting some devlogs from this project I have here, where I'm now currently in the process of writing networking code. And I will also be posting some more tutorials for other stuff I figured out while I'm developing this game. Alright, thanks for watching.